All right, in lesson 8.3, we are going to start taking a look at piecewise functions. But before we do that, we need to do a little bit of a review that's going to scaffold into what we are learning. So let's review. Graph the following equations on the same graph. So if we were to take a look at these, all right, our first equation is f of x, sorry about that shaking, equals 2x minus 1. Remember to graph our starting value. We start at -1, so go down to -1, make a point, and then our slope tells us to go up 2 to the right 1 for our next point. So up 2 to the right 1, up 2 to the right 1. Okay, and we would do that on both sides, down 2 to the left 1. And from there, we would see that we have our straight line. Okay, that's the first one. For the second one, we're going to start at 2. And we are going to, because it's negative, we're going to go down 3 to the right 1. So 1, 2, 3 over 1, 1, 2, 3 over 1. Okay, all the way down. And we'd have our second line. Let me try that one again. That was bad. That was bad. Okay. And then for our third one, we are going to start at 5. We're going to go up 0 to the right 0 because there's no other number. So just at 5. Okay, and we're going to have this line here. So that's just a quick review of graphing three equations. But let's suppose we put some rules in that. Okay, now it says, now suppose I have rules that says if x is negative, plug it into f of x equals 2x minus 1. Where we graph it, okay, so where would we graph this? Okay, if it has to be negative, we're going to graph this everywhere x is less than 0, because everywhere to the left of 0 is negative. If x is greater than or equal to 0, but less than 4, we're going to use the equation -3x plus 2. So where do we graph that on our domain? We know that it has to be greater than or equal to 0, so x is greater or equal to 0, but less than 4. Okay, and then it says if x is greater than or equal to 4, plug it into h of x equals 5. So when are we going to use that? We're going to use that when x is greater than or equal to 4. Okay, so having said that, how does that change our problem? Well, let's take a look. Okay, is there a way I could write all of these functions as one? Well, let's think about this. Or actually, before we do that, let's graph it. So we're going to graph 2x minus 1 for anything less than 0. Well, same thing. We're still starting at our -1. Okay, we're still going to go up 2 to the right 1, but we want it only on the left side. Okay, so let me zoom in again. So we only want it when it's less than 0. So this open circle right here, or this closed circle right here, we're actually going to make it an open circle. And everything that is less than 0, we're going to graph. Okay. Then we said, well, we're going to graph -3x plus 2 from 0 to 4. So we'd start at 2. It's included because it's or equal to. What do? We go down 3, 1, 2, 3 over 1. 1, 2, 3, 1, 2, 3 over 1. And we're going to do this all the way to 4. So 1, 2, 3 over 1. 1, 2, 3 over 1. But that's going to be an open circle. And now we're going to go down this way from here to here. Okay. And for our last one, for anything greater than or equal to 4, we're going to graph that last one, which was just at 5. So we're going to go up to 5, color it in, and everything to the right. So is there a way I could write these all as one function? Well, there is. We can say that we're going to use the equation f of x, and I don't need to write that again because we already saw it down here. We can say that the equation f of x equals 2x minus 1 when, actually we won't use that, we'll use a comma. It'll be easier for us. When x is less than 0, we're going to use -3x plus 2 if 0 is less than or equal to x, which is less than 4. And we are going to use 5 if x is greater than or equal to 4. This is called a piecewise